Now, issue 1. This is an inequality, not an equality. Issue 2. You have this desire to cross multiply, don't you? Now, I may have mentioned this before. If I haven't, I'm going to mention it now. Cross multiplying is a gimmick. What you're really doing is clearing fractions. I think I've mentioned that before. If not, I'm mentioning it now. So to clear the fractions, I'm going to multiply through by x plus 2 and x plus 4. Is that right? And so that makes sense. Multiplying both sides by the same thing makes sense. And if I reduce these, I'll multiply these two, which is like cross multiplying. And I'll reduce these, so I'll multiply these two, which is just like cross multiplying. But we have a huge, huge problem. Is this positive or negative? You don't know. It has a variable in it. So if you're multiplying both sides by something, how do you tell whether to switch the inequality or not? Whether it's positive or negative, right? Well, if you don't know, I think this does work. You can't do any of that. Don't cross multiply. Because you don't know whether to switch the sign or not. But you can do this. You may not want to, but you can. You can do this. What did I do? I subtracted the right-hand side to both sides, right? Or I made the right-hand side 0. That never requires reversing the inequality, right? If I'm older than you, I think I am, and we subtract 5 years, I'll still be older than you. We can subtract anything we want from your age and my age, and I'll still be older. Okay? Adding, subtracting never changes. Multiplying a negative does, right? You with me? So then, now, is this the common denominator? Is this the first numerator? Minus. Is this the second numerator? And getting a common denominator never changes the inequality. And don't clean up the denominator. Leave it, leave it, leave it. And I hope that's right. All right? Now, yesterday, we had this second degree thing and was either less than or greater than 0, whatever. And this thing could be 0 or what? Remember? Positive or negative, right? Those are the three things we did at the very beginning of the notes. You have the 3 columns: equal to 0, less than 0, greater than 0. And that determined what we did with the number line, right? Now, with a fraction, the same kind of things happen. Could this fraction be 0? When? When is a fraction 0 in general? When the numerator or top is 0. So let's do that. 6x plus 10 equals 0. And kick the 10 over, divide by 6. We get x equals negative 5/3, I believe. That's when the top is 0, meaning the fraction is 0, right? The fraction could also be positive. It could also be negative, depending on what I plug in for x. There's one more thing that a fraction can be that a polynomial cannot be. What is it? 0, positive, negative, one more thing. I could see why you'd say no solution. It's probably that same flavor. It's undefined. When is a fraction undefined? 0 in the denominator. So, I'd say if x equals negative 2 and negative 4, the fraction's undefined. How are we doing? Okay, so here's what I'm going to suggest. We do the same thing. And depending on what number I pick on the number line, the answer will either be 0, positive, negative, or undefined, right? Now, I want this ultimately to be what? Positive, greater than 0. So let's do a process of elimination. Okay, you ready? Issue 1. It's going to be 0 when x is negative 5/3. So, can x be negative 5/3? No, I don't want it to be 0, do I? So, I'm going to use the old notation for now, but I'm going to revert back to the new in a second. I'm going to put a little circle here, just to remind myself that it can't be that. Now, when is the fraction undefined? Negative 2. Negative 2 is to the left or right of that fraction? Yeah, because negative 6/3, right? That's negative 2. So here's negative 2. And here's negative 4, let's say. And I don't put a 0 in because it'll confuse you. You think that 0 is another point to worry about. I'm leaving the 0 off. Can x be negative 2 or negative 4? No. Now, let me change the problem just for a moment to show you what to be careful of. If I change this to or equal to, there are people in the class that go, oh, no, you fill them all in. That's the rule. If it's or equal to, you include everything. Wrong, wrong, wrong. Don't use rules. All that means is that the top can be 0, right? So this one will be filled in if I was doing that problem, which we're not. But, the denominator still cannot be what? 0. So those are going to be open. Do you see why you have to think and not use a rule? Because I'll bet you many of you up until that moment thought, oh, or equal to, you fill them all in. That's the rule. And you don't think. Do you? So, I have eliminated when it's 0. I have eliminated when it's undefined. What's left? Positive or negative? We're going to do the same thing we did yesterday. Let's take a number to the left of negative 4. Pick a number. Negative 5. I'll do the same lazy thing I did last time too. I plug in negative 5 to the top, and it's negative, I don't care. I plug in negative 5 to the bottom. It's negative here and negative here. Agreed? What's a negative over a negative times a negative? Negative. Pick a number between negative 4 and negative 2. I just knew you were going to pick that. And so I plug into the top, it's still negative. To the bottom left, it's negative, but to the bottom right, it's positive, isn't it? What's that? Positive. You test the other two regions. So what happened between negative 2 and negative 5/3? Positive? Okay, let's back up. What did we choose between negative? So negative 2 is like negative 6/3, right? So what you could do is, let's see, what's between these? If I change everything to sixths, like negative 12 sixths and negative 10 sixths, you could use negative 11 sixths. How's that? And if you use that, I think that makes this one positive. So that's negative, I believe. Is that right? And then to the right of negative 5/3, I believe that's positive. And what did I want? Oh, I should see down here, my bad. What did I want? Positive. So I want this region, and I want this region. Okay? Do I include the endpoints in the original problem? No. So then I go from parentheses, what? Negative 4 to negative 2, and then what? Before that, which you're right, union, and then before that, parentheses, negative 5/3, comma, infinity. So a lot of small twists and turns. Don't cross multiply. Don't just fill everything in if it's or equal to and leave everything blank if it's not. Test for 0, top is 0. Undefined, bottom is 0. Positive and negative, test regions. Okay? Same thing here. Don't multiply through to get rid of the fractions, because it's a variable expression, isn't it? So see if you can get the right side to be 0 and the left side to be a single fraction. All right, be careful, be careful, be careful. There's subtraction here, and there's subtraction here. So what I did is I said, okay, I'm going to do the subtraction later. Let me just package these three groups and do them first. So we don't have to worry about too many things at once. And then when I subtract, I'll make sure I distribute and get the signs right. Okay? And so I'm hoping what I did was right. Be sad if I'm warning you about this and then I'm wrong. Okay? Can I factor this guy? X minus 4, x plus 1, and x minus 1, x minus 3. Leave it in factored form so we can see stuff, right? And I'm going to make this one right now or equal to. So we have to deal with that extra step that I want you to consider, okay? Now, here's our number line. And we'll start with our process of elimination. When is the fraction going to equal 0? When is this going to equal 0? 4, correct. And it can be 4, I'm going to put a dot there. And negative 1, it can also be that. So these actually do exist. They're going to be part of the graph. I'll bet you down the road they're going to be brackets. Right? When is this fraction going to be undefined? At 1 and at 3. Those have to be open circles or not included, because I can't have the fraction be undefined, right? But that's where it happens. Fraction 0, top is 0. Fraction's undefined, bottom is 0. What's left for the fraction to be? Positive or negative? You go ahead, test the 5 regions, and see what you come up with. Okay, from left to right, first group. Positive, then. Do you think it's always alternating? Nope, don't bet on that. Maybe usually, but you know those test and quiz questions are always the exceptions, aren't they? All right, so which did I want? Negative. So, from left to right, what do I write down? Bracket, good. Negative 1, comma, 1, parenthesis, union, parenthesis, 3, comma, 4, bracket. How are we doing? Good? Now, for those that care, if I set this equal to y and graphed it, well, then first of all, x-axis, y-axis, and you won't know what I'm doing, but that's okay. I think the graph looks something like this, where it's positive here, negative here. And then we have a vertical asymptote where it's never going to be x equals 1. And then it's always positive here. Another vertical asymptote when x can't be 3. And then it's negative here, 0 here, and positive here. And then it's got this ceiling thing that we'll talk about at some point in your lives, where the horizontal asymptote is y equals 1. I'm sure you care.